Today we're going to talk about elasticities. Elasticities are a very commonly used concept in economics, but it's one that often gives students some struggle. And so I want all of you to really pay close attention to the formulas and some of the definitions, because they can get tricky if you're not careful. So the goals that we have here is to talk about elasticity, which is how responsive changes in price, or how responsive, changes in quantity demanded are to changes in price. And we're going to talk about that in terms of price elasticity, but we're also going to talk about some other concepts, income elasticity and cross-price elasticity. We're going to do this on both the demand side and the supply side. And we're also going to talk about how this concept of elasticity is related to total revenue. So our first definition is that the price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. It tells us how responsive the quantity demanded is to anything that happens to price. It's always expressed as a positive number, and that's going to be a little confusing here in a little bit, because you're going to calculate price elasticity of demand and find that it's a negative number. But we talk about it as if it's a positive number because it's easier to think of, to conceptualize when it's a positive number. So don't let that confuse you. A couple of definitions here. The demand is called elastic if, when you calculate the price elasticity of demand, the number you come up with is greater than 1. It's called inelastic if the number you come up with when you do the calculation is less than 1. If you come up with exactly 1, we have a third term that's not shown on this slide that is unit elastic. So here, let's do an example of this. We're trying to calculate the elasticity around the point labeled C. Now, the formula you're going to be given in principles is called the midpoint formula. So you use two reference points. We're going to have reference point A and reference point B, and we're going to use that to estimate what is the elasticity somewhere close to the point C. And you see the formula here. That was the generalized formula you saw on the previous slide, but there's a more detailed formula, which you're going to see next, which is this formula you see on the right. Now, let me give you a little hint here. Regardless of which point you call point 1 or point 2, make sure you keep the price and the quantity for that point together. In this example, point A is going to be point 1, and then B is going to be point 2. So our calculation is we take the quantity associated with point B, Q2, subtract from that quantity associated with point A, Q1, then divide it by 1/2 the sum of the two quantities. That's the numerator of this fraction. We then, in the denominator, take the price associated with point B, which we're calling point 2, and subtract from that the price associated with point A, then divide that by 1/2 the sum of the two prices. So if we do this, here's the numbers that we come up with. And you see that we would have gotten a negative number, but they're taking the absolute value of that and giving us an elasticity of 1.27. Now, since it's greater than 1, we would say that point C is elastic. Now, the next thing we need to talk about is that elasticity is not the same thing as slope. In fact, if you have a point that would be what we call perfectly inelastic, remember it has a value less than 1, it'd be elastic. If it's perfectly elastic, the elasticity value would be 0. So if the demand is perfectly inelastic, the demand curve is straight up and down. If the demand curve is perfectly elastic, meaning that quantity has a huge response to changes in price, elasticity here would be equal to infinity, then the demand curve is a horizontal line. So now the next thing we want to do is to talk about where the various regions are along a demand curve that determine the elastic and inelastic portions of the demand curve. So you see right there where the demand curve crosses the vertical axis is where the elasticity would equal infinity. That's the point where it is perfectly elastic. As you go down the demand curve, the elasticity diminishes from infinity. And as long as it's greater than 1, it's in the area we call elastic. Then it gets to the midpoint where the elasticity is equal to 1. Now below that, the elasticity is less than 1. And so that's going to be the inelastic area of the demand curve. And finally, where it's on the horizontal axis, the elasticity is equal to 0. Now, elasticity will change along these straight line curves. And looking at a supply curve, we see that the same thing on supply as it is on demand. Elasticity is equal to infinity, where the supply curve crosses the vertical axis, the price axis. It declines and approaches 1 as it is going up that supply curve. On the next one, we see that the where it crosses the horizontal axis, it's equal to 0, and it increases and approaches 1 from that point as it goes up the supply curve. Now, what this means is that if a supply curve crosses the vertical axis, it's going to be an elastic supply curve. If, on the other hand, it crosses the horizontal axis, this is going to be a supply curve that is elastic. So now let's talk about the price elasticity of supply doing the formula just as we did before. The formula for supply elasticity is that percentage change in quantity supplied divided by the percentage change in price. That will tell us the same kind of information. How responsive is the quantity supplied to changes in the price? And we also have the same kind of definitions we had before, that the supply is elastic when that value is greater than 1. It's inelastic when that value is less than 1. And here we've got an example where we can run through the calculations. There you see the generalized calculation, percentage change in quantity supplied divided by the percentage change in price. Here you see the midpoint where we want to estimate what is the elasticity around that point. And here's the formula, just like you saw before. Remember, Q1 is associated with point A, P1, Q1 is associated with point A, P2, Q2 is associated with point B. So we plug those numbers in there and you see that we get an answer that it is 0.18, which would say that this supply curve is inelastic. Now let me very quickly say something about this. The way that this image is drawn, it looks like this is an elastic supply curve because it's crossing the vertical axis, but that is not correct, and it's a problem with the way they draw this line. They're not showing you the quantity all the way down to 0. They're only showing you quantity at 476, so you get the impression that this is crossing the vertical axis, making an elastic demand curve. You guys just calculated it as inelastic, and if they had drawn the entire curve, you would see that it would be crossing the vertical axis, the horizontal axis, not the vertical axis. So I apologize for this image kind of leading folks astray. So what makes the supply or demand more or less elastic? Generally speaking, the more substitutes a good has, the more elastic will be its elasticity for supply or demand. If it has things that you could change to, a substitute, then when the price of the good goes up, people are simply going to shift their consumption to the other good. So the substitution is one of the most important things in determining whether or not something is more or less elastic. Now, beyond substitutions, there's a number of other factors that we need to consider. First of all, the time period. Is it a short period of time or a long period of time that we're looking at? the degree to which a good is a luxury as opposed to a normal good. How do we define the market? And you guys are going to see this when we are doing the end of chapter questions, that market definition is going to come into play. Is the market narrowly defined, or is it defined rather large? And then finally, how important is this good in your budget? Is it something that you don't spend very much of your budget on, or is it something like rent or a car payment or something like that that you spend an awful lot of your budget on? Now, the next thing we're going to talk about is a related concept within elasticity, and that is, how does it affect the elasticity has a strong effect on revenue, and we need to understand exactly how that effect shows itself. If the good is elastic, in other words, elasticity of demand is greater than 1, an increase in the price will decrease total revenue. If it's equal to 1, unit elastic, it has no effect on total revenue. And if it is less than 1 or inelastic, an increase in price increases total revenue. So if you have a good that has a lot of substitutes and you want to increase revenue of your firm, the trick is to lower your price, not raise your price. But if your good is one that has very few substitutes and you want to increase revenue, the trick is to increase price, not lower price, to get an increase in revenue. So let's think about this from using that same demand curve we had before. So in the areas that you've got A and B, we're in an area where at point E, we're in the area where we are inelastic. So the total revenue is equal to the price times the quantity. So we've got 4 times 6 is 24. If we change the price, we take it to a price of 6. Now we're in the elastic zone, and we raise the price to 6. We get a reduction in quantity from 6 to 4, an increase in price from 4 to 6. We get the same revenue. That's if it's in and around a unit elastic point on the graph. Now, let's see what happens when it's inelastic. So now we've got points that are clearly in the inelastic portion of the demand curve. And let's see what happens. So here we are at point G. At point G, the price is 1, and the people are going to buy 9 units, which gives you $9 of revenue. If we increase the price from 1 to 2, the quantity demanded will go down from 9 to 8, but not enough to offset the change in price as far as the revenue is concerned. Revenue is now 2 multiplied by 8, so it goes up to 16. So here in the inelastic area, if you raise price, you get an increase in revenue. But let's look at the opposite of that, the elastic demand. So now we've got an area of the curve that's elastic. Let's start at point J. At point J, the price is equal to 8. Quantity demanded is 2, giving you a total revenue of 16. Let's raise the price from 8 to 9, and we only sell 1 unit. Our revenue goes down from 16 down to 9. So here is a graph that'll kind of help you remember the effect. If it's elastic and you raise the price, revenue's going down. If it's unit elastic, nothing's going to change. If it's inelastic, if you raise the price, revenue increases. Everything is reversed when you think about a decrease in the price. Okay, the next thing we're going to talk about, well, I'm having a little trouble getting the slide to advance. So what I'm going to do, let me pause the recording just for a second, and I'm going to figure out. Okay, figured out how to advance the slide now. There's other ways you can think about elasticity. And the first one we're going to talk about is income elasticity. It has a similar generalized formula, but now we're looking at the percentage change in demand based upon changes not in price, but in income. In other words, what happens to your demand for a good when you get a raise in pay or maybe you get a decline in your income? Now, we think of this in terms of normal goods and another term you're going to see in just a minute, which is called inferior goods. But let's talk about normal goods first. Normal goods are those whose consumption go up when your income goes up. So you get a raise at work and you buy more of this good. If the income elasticity is between 0 and 1, then we would consider that a necessity. But if the income elasticity excuse me, is greater than 1, we would consider that a luxury. Now, the next thing I was going to talk about is the inferior goods. Now, those are things that you consume less of as your income goes up. So think of something maybe that you consume now as a college student. You don't have a lot of money. So these are things that you buy, but as soon as you get out of college, you get a good salary. These are things that you may be buying less of. The next one we want to talk about has to do with what happens to the demand for some good when the price of a related good changes. Now, the same kind of generalized concept is the percentage change in demand, but this time divided by the percentage change in the price of that related good. Now, here we can talk about the relationship between the goods. Are they substitutes? In other words, is this Coke versus Pepsi? In that case, this cross price elasticity will be greater than 1. Or are these complements, peanut butter and jelly, goods that are consumed together? In that case, the elasticity is going to be less than 1. Now, the next thing we want to discuss is what happens when you have shifts in the supply or the demand. So the idea here is that whichever is more elastic, whether that is demand or supply, then that is going to have the more elastic curve, demand versus supply, is going to have the greater effect on quantity and a smaller effect on price. So here we see an example where demand is relatively elastic. Compared to the supply curve, it's flatter. So let's see what happens when we allow the supply curve to shift out. So as the supply curve shifts out from supply curve S0 to supply curve S1, notice here, the price goes down, but the quantity goes up to a higher degree. You get a bigger increase in quantity than you had a decrease in price. So that's because the demand is more elastic than the supply curve. Now let's look at another example. Here we've got the exact opposite. The demand curve is steeper than the supply curve. So it's the supply curve that is more elastic than demand. So let's let the supply curve go out just like it did before from S0 to S1. You see the price dropped fairly dramatically and you had a fairly small change in the quantity. Price went down by a larger degree than the quantity went up. So that leads us to the end of this first video where we're talking about elasticities. What I want you guys to do, I want you to make sure you've read the chapter very, very well. You've watched the video. You even have access to all of these slides on Moodle. And when we get together on Zoom during our regular class time on Tuesday, I'll be ready to answer any questions that you guys have. So thank you for bearing with me as I make my first video. This is going to be the way things are going to go for the rest of the semester. I will make a video of the chapter going through the slides. I expect you guys to watch the video, read the chapter before we get together in class, and then we will talk about it during our regular class time. Hope you guys are doing well. I know this is a challenging time, and I thank you for your patience as we try to respond to a very unusual situation that we have going right now. Thanks again, guys. Talk to you when we get in class.